So this is 3.1, B as in boy, and we're doing example 4 here. And on this one we have, example 5, we have 2 times 3x plus 1, and we're going to add 4 times the quantity 2x minus 5. So again, we're going to do what's in the parentheses. There's nothing we can do there. So we're going to distribute here 2 times 3x and get 6x, 2 times 1 and get 2. Parentheses go away. 4 times 2x is 8x, 4 times negative 5 is negative 20. Okay, so we just distributed both this one and this one. Now we're going to look at combining like terms. Well, I have a 6x here, and I have an 8x here. Let me remember to grab my sign with me. I have a plus 2 and a negative 20. So those are like terms. So I'm going to combine the ones in the box. 6x plus 8x is 14x. And positive 2 minus 20, or positive 2 plus negative 20, if you want to write it that way instead. Signs are different. Take the difference between the two to put the sign of the largest number on there. And I have 14x minus 18. The next section is called the value of an algebraic expression. And what that means basically is they're going to give you an algebraic expression, such as example 6, where they have negative 1/4 x plus 5. And they're saying to you, what would happen, what would you get for an answer if the x were equal to negative 8? If we took this negative 8 and put it in right there, what would our answer be? So let's do that. We're going to put a negative 8 in there for x, and I like to put a parenthesis in there just to say everything in that parenthesis is what I'm replacing x with, plus 5. So now I'm going to take negative 1/4 times negative 8, which is negative 1/4 times negative 8. Let's make it over 1 to make it a fraction, just to remind you of what's going on here. Multiply these two. Negative 1 times negative 8 is 8. 4 times 1 is 4, and tag the 5 on there. 8 over 4, it's an improper fraction, and if we were to divide, we get 2 plus 5 equals 7. So, when we take this expression and we put a negative 8 in for the x, and we go ahead and multiply and add and all that, our answer is 7 when x is negative 8. So that's what's called the algebraic expression, the values of algebraic expressions. Now, I want you to look at some terms having to do with facts from algebra, because we're going to be doing some angles and that kind of thing. Now, when we're talking about measuring, when we talk about a ruler, and if we go from there to there on a ruler, it's broken into 12 inches. Well, when we're dealing with a circle, we can't talk about inches. We're not talking about how long something is, but we are talking about a measurement. We're talking about a measurement around the circle, about how many little units here it takes to go all the way around the circle. And each one of those little units is called a degree. So we've got a degree. There are 360 of those little degrees there. Just like there's 12 inches in a foot, 36 inches in a yard, etc., there are 360 little degrees when you go all the way around this circle. And when we're talking about angles, an angle is, and let me show you here in the green, is an angle is just one of the distances from one part of the circle to another part. So that right there is a certain distance from there to there, and that is a certain number of degrees. So if it took 40 little degrees to get up there, we would say that that angle is a 40-degree angle. And we have different names for these angles. And let's go ahead and put a couple on here. If we have an angle that maybe is halfway around the circle, so if we've got this huge circle and we go from here all the way halfway around to where it's a straight line. That's called a straight angle, and it is 180 degrees. It's half of the entire revolution of 360 degrees. If we have an angle that goes from a point or a place here straight up and down, and we have a little box here, that means it's a right angle or it's a 90-degree angle. And they'll always tell you if it's a right angle by putting a little box there. They don't even have to write 90 degrees in, you just know. An acute angle is another kind of an angle that we're dealing with, and it is an angle that is somewhere between 0 and 90. So it will fit in here somewhere. So it will look like this, it will look like that, but it's always going to be less than the 90-degree angle. The other kind of angle is called an obtuse angle. And an obtuse angle fits, let me show you that in red. An obtuse angle will start here, and it will be somewhere between our 90 and our 180. So it will, and let me draw you one in blue here. It will be here, and the other side will be here. So it will go from here to here. So somewhere between this red here. So it's anything bigger than 190 and or 90 and less than 180. So one without the circle might look like that. And let's say that's 120 degrees. So it's bigger than 90 but less than 180. Now we have some relationships between several angles, and those are called complementary and supplementary angles. So a complementary angle is an angle that I need to put with another angle that when I add them together I get 90 degrees. So if this is a 30-degree angle, the complement of that 30-degree angle would be the other angle that I would need to add to that 30 to give me 90. So 30 plus 60 is 90. So that means that the 30-degree angle is a complement of the 60, and the 60 is a complement of the 90. What does it take to make the combination of the two angles 90 degrees? So whatever angle it takes is a complement of the other one. The same is true when it comes to what's called a supplementary angle, but we're talking about a straight angle here. So we're talking 180 degrees. So what two angles added up give you 180? Well, if I tell you that this is a 30-degree angle, well, what do I have to add to the 30 to get 180? So the supplement to a 30-degree angle is 150. I have to add 150 to 30 to get 180. Or if I give you 150 and I say, what's the supplement of that? You're going to say, well, if I add 30 to that 150, I'm going to get 180. So the supplement of a 150-degree angle is going to be a 30-degree angle. And that is it for lesson 3.1.